Hello everybody. Unfortunately it took me a little longer for the next performance test with forced ventilation. But anyways, meanwhile I did it. It looks like that. I took the strongest fans I was able to find. They produce lots of airflow and keep that airflow upright even though there's some air friction. So they produce also lots of pressure. Yeah, that's what it looks like. Lots of airflow through the machine itself and also along the rotor. The measurement was quite noisy because the fans consume additionally twice 12 volts and 2.6 amps, so we've got additionally more than 60 watts, almost 70 watts losses just for cooling. After performing that test, you can see the results over here again. The results are quite satisfying, but not completely. Maybe you got the results from the previous measurement still in mind, and the summary of everything looks like that. You can see, over here, the measurement without additional cooling, the first performance test, so to say, and the increase in temperature, which was critical, especially for the rotor of the motor, but for the generator as well. And with additional cooling, the increase in temperature was much less, and the most benefit was for the stators of motor as well as for the generator. For the rotors, it did not help as much, just 10 Kelvin. But honestly, during the measurement in my tiny little lab, the ambient temperature increased by 7 or 8 Kelvin respectively. And if we take that into account, the increase in temperatures are basically the same, just reduced by that increase in ambient temperature. And finally, probably the most important numbers are those ones over here, in how far the forced ventilation, that massive airflow, reduced the increase in temperature. For the stator, each-wise, it was 20%, and for still unknown reason for the generator 33%, and the rotors cooled down by 70 or 16% respectively. So now the temperatures are safe, but still a little high because those performance tests were about 7.2 kilowatts mechanical power, and the idea was to get closer to the values the manufacturer told me. So the motors are designed for 12 kilowatts mechanical power, and somehow I've got the bad feeling that they won't survive thermally. But currently the test setup is not designed for 12 kilowatts mechanical power, because that means I need to put in around about 4 kilowatts losses, and the lower power supply is capable for 72 volts and 50 amps only. So I will need to organize a second one, and then I'll start some measurements with more power, mechanical power between the machines, and expecting of course more losses, like as I said before, 4 or 5 kilowatts. And then we will see how fast the temperature increases and for how long at least we can have the 12 kilowatts at 90 volts with forced cooling. Alright, so far, see you soon, goodbye.